everyone, and welcome to this new AWS Lambda coding session webinar. I am Alex Casalboni from CloudAcademy, and today we'll go through a very brief introduction of the main AWS Lambda and serverless concept, and then I will demonstrate 5 different demos trying to cover the main AWS Lambda use cases. For example, API Gateway, S3, DynamoDB, and so on. First of all, a very brief introduction about myself. I'm a software engineer. I've been working into the web development field for quite a few years now, and I was lucky enough to join CloudAcademy a bit more than 3 years ago when I started coding in Python, which is also the language that I will be using today for our demos. So first of all, very quickly, what is serverless and why is it even a word? So let's say serverless was born about 2 years ago, and that was introduced by AWS. And I personally believe that the main advantage of this new approach to application development is that you can almost neglect administration, zero administration. Meaning that you do not have to manage your servers. That is the main, that's why it's serverless, right? Although there are servers, but you don't manage them. It's much simpler. And then there are other advantages. You only pay per execution. You can design your code in an event-driven fashion, basically because your new unit of scale is not the operating system, it's not a container, it's not an application, but it's a single function. Meaning that if you follow the microservices-oriented design, you can really speed up your development and simplify your workflow, just removing servers from your daily tasks. So what about Lambda? Well, Lambda comes with all the benefits of serverless. And I think here the main point is that you can achieve scalability and very high availability without managing any infrastructure. So it's all managed. And of course, you still have to deal with operations, but all these operations are pretty developer friendly, meaning that you can, if you want, do everything from a browser console or with some API calls. So you can maintain your code, version your code, and test your code in a very easy and user-friendly way. Of course, since it is AWS, you also have everything that comes from the ecosystem. So you have every possible integration with all the other services. We will see some of them later in the demo. And of course, one of the other mantras is that you never pay for idle, because there is no idle, because you do not pay for servers. You only pay for invocations of your functions. So you don't even have to talk about idle at all. And also one of the main use cases for Lambda is that you can attach a RESTful interface to it through API Gateway. That's the first thing we're going to see today. And so almost for free, you can have a RESTful interface over any Lambda function you can develop and think of. Great. So we'll go through 5 different demos, and I would like to show you how to integrate Lambda with the most important AWS services today. And during the last webinar with Austin Collins, we talked a lot about the best practices and what's the best coding patterns are, with a special reference to the serverless framework. If you don't know about it, please check it on our blog or on serverless.com. And so we went through, let's say, the 3 main approaches that people are taking when they develop new AWS Lambda systems, let's say. So the first one is the nano services approach or pattern, where every single Lambda function only deals with one single job. So this makes you have a lot of Lambda functions which are simpler, but in a way harder to maintain and Well, also they share a lot of dependencies, a lot of code. It's just more complicated to handle. But so if you see the diagram here, like every section, every color little section is like a logical unit. So each one of them will have more Lambda function. Let's say if you have a CRUD logic, you will need to have one Lambda function for get, one for post, one for put. So this adds a lot of overhead in your operations and code maintenance. So the second pattern, which is more suitable in case of HTTP interfaces, is that you have one function for n different jobs. So for example, you will handle all the get, post, put operation over your resources with one single Lambda function. So this allows you to have much fewer functions overall, and it's also much easier to share your code and to organize your code. And also it will make your startup, your Lambda function go faster in a way, because if you don't call your Lambda function for long enough, the underlying container will be dismissed. And this means that if you don't call the post operation for 1 hour, the next call will be slower. Okay. Instead, if you have all the get, post, put logic into one single Lambda function, this issue will not be as important, because your Lambda will keep being warm and will not get cold. So this is the cold start issue that we talked during the last webinar. And then there's the new monolithic approach where you manage all the interaction between the client and the server with only one function and GraphQL, which is a great new tool to let the client specify what kind of structure it's expecting as output of your API. And this is a new approach where everything is managed by one single function that aggregates data and returns the right structure to your clients. And it will make your API versioning and maintenance much, much easier. We might have another webinar just about this new approach. I'm very curious to explore it myself. Okay, great. So let's start with the first demo. I think most people are using Lambda to build RESTful HTTP interfaces. And I think this is one of the main use cases. So let's focus on this one for a while. And let's start from scratch. We'll go through like all the steps, how you build a RESTful interface, how you design your mapping templates, and how you manage stages and policies and versions between Lambda and API Gateway, which can be a bit confusing at the beginning. So let's go into a real AWS console. I'm already logged in my own account, and we can start the new wizard of AWS Lambda. And you can select a blueprint, which is like a ready-to-use, let's say, function that you can customize. But in this case, let's just build everything from scratch. And I'm really happy to be able to show you this new interface, which was released just a few days ago or weeks. So this will make your life much easier whenever you want to create a new Lambda function from scratch. If you already have an idea of what you want to build. In our case, you will just select the trigger, and you are shown all the possibilities, right? So until a couple of weeks ago, you were forced to build your own function and then go to S3 or go to DynamoDB, go to API Gateway and configure everything manually across all these different services. Now you have this beautiful interface where I can just select API Gateway, create a new API because I have no API. Let's call it Hello World, very simple. And then we have a new resource. Let's say hello, very simple. We want to have a get method, that's fine. We can select a deployment stage, meaning this is how API Gateway manage staging. So you can have a dev stage, a prod stage, testing stage. In this case, let's start with a simple dev stage, which is just a convention. And let's make the API open so we don't have to mess up with authentication authorization. Although this will be a very interesting demo maybe next time. Okay, great. Of course, we get a warning because the API endpoint will be publicly available. And this is a great warning because you don't want to do this in a real production environment. Great. Let's call our function hello, just hello. As I mentioned, we are going to use Python 2.7. And let's just build a new function. We want, as you could imagine, start very simple with just an hello word. Maybe we want to print the event. This will generate a new CloudWatch log, which comes for free with AWS Lambda. And now we will slightly complicate this example step by step so that I can show you how to build, how to create a new version, how to work with aliases, and so on. Okay, great. So we don't need any particular role, so we can just select the basic Lambda execution role, which will allow Lambda to just write blocks. Nothing special. Okay, 3 seconds, great. We don't need any VPC configuration. We can just go. So this review, we configured an API gateway production stage. Well, I think we want to have we said a dev stage, right? Done. Open. Oh, let's just change. Let's say hello again. Awesome. And we called it hello world. Oh, what's going on? I like this user interface, but I have some complaints about it already. Let's say that again. Okay, we should be good to go. Our code is still there. This is great because you can edit your code inline. This is really powerful. Of course, if you have any additional dependency or some particular requirements, you can upload your own code. You can upload it on S3. You can version it. You can do whatever flow you prefer. For today, we are just going to edit code here on the browser, which is just simpler to show to you. Okay, create function. So what happened? We just created a new function. There is only one version, which Amazon AWS calls it latest, and this is the default last version. And we also bound this version to our development API gateway stage. So we didn't do anything yet, but we already had an hello world HTTP API. Okay, this is great. Pretty simple. We didn't do much, but it works. So what we want to do, let me tell you about versions and aliases. So a version is basically you can create a new version each time you make, let's say, a meaningful change in your Lambda function code. And this allows you to have different versions to roll back and to have different stages so that, for example, your development stage can point to a specific version and your production to another one. And therefore, you can test new functionalities and new improvements to your code without breaking the production. This is a very good practice. Aliases are the same. So you can create, as we did for API Gateway, a dev alias and bind it to, for example, the latest version. In this case, whenever you update your code, your development stage will use the latest version of your code. While if you also created a production stage that is pointing to a previous stable version of your code, you will not break anything. So let's just do this. Okay, we publish a new version because we have no version now. Working with the latest is not very recommended. So initial version, publish, right? And as you see, we don't have any aliases yet. Lambda doesn't create any alias automatically. So we can create a new alias. We can call it dev, just dev, and we can bind it to the latest version. I like to do, maybe it's not a great practice, but I like to have the dev environment always updated with the latest versions of my code. So this will make my flow much faster. Great. So what we're going to do now, we go back to our latest version, and for example, we can update the logging. So let's say event is S. We just made a little simple change to our code. We just save it. So now our latest version is updated. And what happens? Our dev alias is still pointing to the latest version, right? So if in our API endpoint, everything is already updated. So if we check our logs now, we will see. Let's do it very quickly. So you can check every CloudWatch log and see just what happened. So this is the event, and we can see the latest event is great. Okay, now we have a production API, a development API gateway stage bound to our latest version, because that's what we did. So let's go and improve this. Let's go to API gateway. As you see, an hello world API was created with a hello resource and a get method. This is what you used to do until a few weeks ago manually. Okay, this just happened automatically. As you see, the Lambda function integration is just pointing to hello. This means that API gateway will just reference to the latest version of our Lambda function. So what we can do, we can say, please point our get hello method to the hello development alias, right? So we authorize it, and Lambda will ask us, do you really want to provide the permission to evoke this alias? Great, so let's do it. We can deploy our API to the dev stage, and done. So we didn't change much, but you will see this will be very useful when we start having more than one stage. Okay, what we want to do now is we want to create a new stage. We can call it production. So first we go to AWS Lambda. We create a new alias. We call it prod, just prod. And let's say that we bind it to a stable version of our API, not to the latest one, right? Now we have, as you can see, two different aliases, dev and prod. Dev, always latest, prod, stable version. How do you have also an API gateway bound to our production Lambda function? Well, you just configure it here with the Lambda function integration. You say prod. You will be asked again to provide permission to API gateway. It's very easy from the console. You will need to make a few API requests manually. And then we can redeploy our API, but this time into a new stage. Let's call it production prod. No particular description. Great. So now you can see here we have two different independent stages, and they should both work. Right. Now we have a dev and a prod. They are the same, although they reference to two different Lambda functions, two different Lambda aliases. They are basically the same code so far. So let's go to our latest Lambda function version and make it a little bit better. Let's say hello world is great. Let's make it more dynamic. Let's take an input parameter. So Lambda will provide us an event object, which in Python is just a very simple dictionary. So we can do something like event.getName, and in this way we will fetch the name attribute of event, and we'll put it into a name variable. How do we update our code? We just say hello name. This is how we do it in Python. Very simple. So, but what if name is not provided? This is really like if I keep calling my API, what's going to happen? So let's say we want to still say hello world, right? If no name is provided, hello world. Okay, great. We can save our function. We can already test it here in the console. We can provide a sample event. Let's say no event at all. What's gonna happen? Hello world. Let's say configure event. Let's say name equals CloudAcademy. And we test it, and it should be hello CloudAcademy. Great. So it works in Lambda. Now, how do we make it work through the API Gateway endpoint? So if I call my dev and my prod APIs, they still work, right? As if you remember, our dev alias is pointing to the latest version. So our API Gateway dev is already updated. So what we expect to do is we would like to say something like name equals CloudAcademy, and this should work, right? But it doesn't. It doesn't because you have to tell API Gateway where to fetch the name parameter. And this is very much more automatic if you make a post request, because this is done automatically by API Gateway. Since we want to do a get request in this case, we need to tell API Gateway how to deal with a get request. So let's go into the integration request. So we want to deal with the dev alias again. And so what we do is you add a new body mapping template. So for each content type, for example, application JSON, you can specify a mapping template using the velocity template. So in our case, we just want to add a name parameter, right? You use input.params name. In this way, we are telling API Gateway to just take any parameter from query string, from post, from the body, from everywhere, and just map it into a name event parameter. So let's see if it works. We just save, right? This is not enough. We also need to redeploy the API Gateway, because if you only change the Lambda function, it's not a big deal. Everything is already configured. But if you change the API Gateway configuration, you will need to redeploy your API. So we are done. So what happens? I would expect this call to render hello CloudAcademy. Let's see if it's correct. It does. Amazing. But what about our production environment? Should it print the same? Well, let's see if it does. It does not. Why is this happening? Well, because our production alias is pointing to a previous version, right? So let's publish a new version of our Lambda function. Let's say dynamic name, publish. And now, so the dev alias is always latest, great. But now we want to say that our production alias will be pointing to this new version 2, so that also the production API will have a dynamic name. Let's save it. Great. So do you expect this to work now? So the dev still works, the prod doesn't, because we didn't deploy it. So as I told you, every time you modify something in your resource configuration and your integration request, you need to redeploy. Never forget that. So let's also add the body mapping template to our production. It should be there already. Let's just save it and redeploy. So if you followed the previous webinar, we talked about the serverless framework. All these operations, all these best practices are already managed by the framework. It will save you a lot of time. Just give it a try. Okay, so we redeploy the production environment. I would expect this to work now. Let's wait a few seconds. Great, production works. Awesome. So this is how you're going to maintain your versions and update your code. You want to work on the latest version. I myself like to have the dev API always updated so that I can test it very quickly. And then I can just update the production alias to the new stable version whenever I have a new one, right? This is a very simple example, but it gives you an idea of how to deal with aliases and API gateway stages. Another recommendation that I will give you is to configure your stage to have stage variables. So in this case, you could make your resource configuration dynamic to use a stage variable. For example, Lambda function alias could be a variable, and you could have for each stage a different value. So the dev will have the Lambda function alias variable valued to dev. And so all the manual mapping will be more automatic. What I did right now was simpler, but it's highly recommended to use a stage variable for this use case. Great. Let's go on. Second demo. How do you use Lambda with S3 events? So you can more or less bind a Lambda function to everything in AWS. Every time you need a little computation, you don't need to instantiate to launch a new EC2 instance or anything. You can, in most cases, just provide a Lambda function to do the job. And let's see how we bind a Lambda function to an S3 event. For example, a new object uploaded into one of your buckets. As a simple example, we are going to listen to S3 and wait for a new file to be uploaded, compress it, and upload it back again to S3 into another position. So we have kind of like an automatic S3 file compression. I don't know if it sounds useful to you, but let's see how it might work. Okay, so I already created an S3 bucket here in my account. I called it Cloud Lambda Trigger. Yeah, still here. There is already an images folder, and we're going to use this as a starting point. So let's go back to Lambda. Let's create a new Lambda function. We could try to use maybe a blueprint. So there is, if you select Python, you can choose a blueprint. This one looks good, S3 get object Python. Let's use it. So we can bind our Lambda to an S3 event. You just select the right bucket. We want to listen only to new file. So let's say put. We want to listen to only to this images folder. So we can use a prefix. And let's say we only want to listen to PNG images. We just enable the trigger. We call it S3 zipper. We use Python 2.7. And so here we have the ready-to-use S3 Lambda function from the blueprint. It's not exactly what we need, but I mean the main structure is very similar to what we're going to do. In particular, as you see, we are retrieving the bucket and the key from the event, which is given by S3. And in this case, what the blueprint was doing, it was retrieving the object, printing the content type, and returning the content type. It was a very simple example just to give you, a little schema to start from. In our case, I already have a few lines of code to get started. So this will be our main logic. Let's quickly go through each line. So we're doing the same. So I basically started from the same starting point. I want to upload my file into a new folder. So I'm taking the file name and creating a compressed /same file.zip. So if I upload a hello.png file, I will end up with a compressed /hello.png.zip file, very simple. So we are going to get the object which was given by S3 in the main event, and we are going to write a new object, put a new object into S3 by compressing its body. So the new key will be the new key, and the bucket will be the same. I wrote a very simple compress utility just by using Python core libraries. I think we also need operating system. Okay, great. So the code should be fairly simple. You just retrieve the data, compress the body, retrieve the body, compress it, and push a new file into S3. Sounds pretty simple. It's not weird magic. So let's go on with the AWS Lambda configuration. This is a bit tricky. Never forget about what you're doing in your Lambda and what permissions you're going to need. In this case, we are both reading and writing into and from S3. So if you don't say anything, if you just use a basic row, this will not work. So let's try to do it. Let's try to do this. We are going to use the same Lambda basic execution role, and we will see that it doesn't work. Right? This looks good. There was some error into the trigger. We'll check it later. But let's see if it works. So you can configure a test event. You can select a very sample event from S3. For example, S3 put is already there. We can very quickly change the bucket so the test event is already updated. There we go. And as you can see, if we save and test, we will get a very, very ugly error saying that we do not have the permission, access denied. So we have to set up a new IAM role. So let's create a new custom one. Let's call it new role. Let's say S3 full access. So here the policy that is given by default that Lambda needs. We can add it in line. So we're going to need a role very similar to this one. In this case, I'm just providing global access to S3, although we might constrain our specific bucket. So our Lambda will be able to get and put an object into S3. Right, allow. We have to save our Lambda function. Right. So if everything worked right, I expect to go to my bucket, upload a new image, for example, our logo. We should upload it. And magically, I should go back to my bucket and see, refresh it. Nothing happened, so something went really wrong. Let's see. Oh yeah, because the trigger failed. Let's recreate the trigger. So Cloud Lambda trigger, put images, PNG, enable trigger. So this is very useful in the new console. You can simply enable or disable it whenever you want. Okay, it seems like the trigger was correctly bound this time. So let's quickly delete the file, re-upload it again, and if we are lucky enough this time, we're going to see a new zipped version of it automatically created. Let's refresh. It's not appearing. Great. So great use case. How do you debug Lambda? Well, you want to go into CloudWatch logs and see what just happened. Let's give it a try. Latest. So there was a problem, still access denied. This might be related to IAM. Sometimes it just takes a while to upload the permissions. Let's do it again. Maybe we can use the test event to make things a bit faster. I should have a test event here. We can update it. So in this test event, I'm using the very same file. So I'm just generating the very same event that we previously generated. So it says, okay, let's see this time. Refresh, great. So it worked. I think it was related to IAM. Sometimes it can take up to 30 seconds to update the permission. So we had the file. Our code was working great. Let's see if it's really the same file but compressed. Let's download it. Save as link. Let's say here it's going to be a zip file. Let's open it. And inside we have the same image. Right, great. Okay, so this is the second demo, and we found out how to bind S3 events, and we also managed to create a new S3 file with a different content, of course. You might use it even to have a backup without compression, or to generate gzip version if you want to serve them via CloudFront. You can do any kind of magic with this. If you use S3 for your storage, this is really powerful because you don't have to add all this custom logic into your application, but you can do everything inside the AWS environment. Great, let's go on. So the next demo is about a simple notification service. You can do the very same that we just did. You can configure SNS to trigger a new Lambda function. And in our simple use case here, we are going to log all the SNS messages into DynamoDB. So we can see how to, again, create a custom role to write a new record into DynamoDB. So first of all, we will need to have, of course, an SNS topic. Let's do it very quickly. Create a new topic. Let's call it CloudAcademy webinar test. Sounds good to me. GR webinar. Create topic. Done. So now we have a new topic, and we can publish messages on it. Subscribers will be able to subscribe to this topic and listen to messages, Lambda included. So what's going to happen, we could do this from here and create a new Lambda subscription, but let's see how we do it directly from Lambda. So we create a new one. We, again, could use a blueprint, great, SNS message in Python. Let's select it. Let's select the SNS topic that we just created and enable the trigger. Next, let's call it SNS to DynamoDB, because this is what we're going to do. Great. So the blueprint gives you a very basic structure. So we will extract the message, the given message from the event, and we're going to just print it. Okay, this is not what we're going to do, but let's say this is enough, and let's create a Lambda function that will make it more complicated. Again, now we don't need any custom role, so we can choose a very basic role for this, and we will update it later in order to be able to write into DynamoDB, of course. Great, looks good. Create function. Awesome, everything was there. The integration, the trigger is active. We're not doing much here, so we can just try to test it with a sample SNS event whose message is only hello from SNS. So if our function works fine, we should just say hello from SNS. Great. So what do we do now? We want to create a new DynamoDB object record every time a new SNS message is published into a topic. So this is what we're going to do. As we already did, we are going to extract some information from our message. So the message itself, its ID, the topic ID and the subject. This is what you can log. For example, this is a very simple example. Then we're going to build the item that we will write into DynamoDB. So we will have a primary key called message ID, which is unique, the message, the topic, and the subject, exactly what we just extracted. We can have some logging and just the write operation. So we will log the item and we will write it, and just, you never know, we will also return it. Great. So if we try to test it now, what do you expect to happen? We do not have DynamoDB write permission, so this shouldn't really work at all. Let's see if we are right. Oh, also, I forgot, what is we need to instantiate our DynamoDB table up here. So we'll create a notifications table. Let's do it right now so that it already exists. Okay, this is DynamoDB dashboard. We will quickly create a notifications table. The primary key will just be the message ID, and it's going to be a string. Default settings are great. We have a new DynamoDB table. Awesome. As I mentioned, if we run this right now, it's not going to work because we don't have the permission, right? Oh, we need Boto. Always forget about Boto. Import Boto 3. Save and test again. Okay, great. As we expected, we have a credential problem, right? We don't have the put item permission. We're not authorized to do this. So what we do, as we did previously, we create a new custom role for our Lambda function. This time we'll be a bit more selective, and we will create a new permission to only allow this table to be written. So Lambda DynamoDB notifications. So this Lambda function will only be able to read from this specific table, right? So this is the statement that you will need to insert. So we are permitting any DynamoDB action, just in case, only for the notifications DynamoDB table. So we need the exact ARN. There we go. Let's use the right one. It was right there. Allow. So with this role, our Lambda function will be able to write or read or do anything with our new DynamoDB table. So if IAM is quick enough this time, we should be able to test, although our test event is not really what our function expects, because we expect a mess. No, it should be fine. Let's just test it. It worked. So succeeded. This is the item that we wrote into DynamoDB. It was an example topic, hello from SNS, just some sample data from Lambda. So now if we go into our notifications table, we can scan it and we already see a message, right? This is the message that we logged. Although we wrote this record with a test event, right? What we want to do is to publish every message that is, to log every message that is published into our SNS topic. So let's see if this actually works, right? So our trigger is enabled. So the CloudAcademy webinar test topic will trigger this Lambda function every time a new message is published. Let's see if it's true. So first we need our ARN of our topic. We can publish a new message. Yeah, I got the wrong one. Let's do it again. Copy. This time is right. We can publish a new message. The subject will be hello from my webinar, and the message will be just hi. Very simple. we can just publish the message, done. What do you expect to see? Well, we should have a new message, a new record in our DynamoDB table. Let's query again, and there it is. So let's make it bigger. This is hello from my webinar, right? So all the data that we logged are successfully stored into DynamoDB. So what happened now? Well, I can, what if I re-execute my test? What do you expect to happen? It will be the same message with the same ID and nothing happens, because if you write a new record, if you put a new item into DynamoDB with the same primary key, it will just overwrite the existing record. So this is pretty interesting. If I execute my Lambda function 10 times, I will not have new duplicated events because of the primary key, right? Okay, so we saw how you can generate new events through SNS. And well, you can do anything. You could call a third-party API, you could log it on DynamoDB as we did, you could write a file on S3, you can just integrate any kind of custom logic with this mechanism. What about the next example? I think a very interesting scenario covered by Lambda is that you can bind it to any source, but you can also schedule events on a periodic fashion, kind of like what you would do with a cron job. So you want to execute a function every hour, every day, every Friday at 5 p.m. Great. You can do this with Lambda as well. So what we're going to do, we'll create a very simple function, execute it every minute, because that's the smallest period that you can configure. And again, we're going to write a very simple event into DynamoDB just to see a very simple use case. So we will create a new DynamoDB table again. This time, let's call it, I think I chose a name already. Let's call it log time. And we will have a primary key called timestamp. So every timestamp will be a unique number, and our function will simply log the time every minute. So you could do anything every minute, every hour, every day. We want to do something quick and simple now. So we're just going to log timestamp every minute and save it into DynamoDB. Could be anything really. So we have a new table. We can very quickly create a new function. We don't need any blueprint this time. Let's just select CloudWatch event schedule. This is how you create like a cron job. And you can just give it a name. Let's say every minute log. Logging the time every minute. Great. So this is how you select the expression. It could be 1 minute, 5, 15, 1 hour, 1 day, or any custom cron expression. Now let's see 1 minute so we can actually see it working in a very quick time. Okay, let's call it time logger, just a logger. We are going to use Python again. I hope you like Python, as I do. And our function will be seriously simple this time. So we will, again, reference our DynamoDB table before the execution starts. We will log the current timestamp. This is how you do it in Python. You just cast the date time into an integer with some magic. And we're going to write a new item with a timestamp primary key and a date time string format in an ISO format. Just very simple, just to see it changing every minute. Some logging and just put item on DynamoDB. You already know that we will need the write permission on DynamoDB, but we cannot use the previous role because we forced that role to be on for the notifications table. So we will need to create a new custom role, right? And it will be very, very similar, just with a different table name. Create a new one. Let's call it DynamoDB time. We add it inline the policy, and we add a new statement as we did before. So we need the ARN of our table, which you can find here in the DynamoDB console. Back, paste, we should be good to go. Allow. So this is the new role selected. I think 3 seconds will be great. We don't need much RAM. Next. Review every minute. Looks great. Create function. Everything worked. So we don't need any particular test event in this case. I would just expect to call the function and have a new log, because every log will be different anyway. So the test event can simply be an empty JSON object, and we can just execute it. I just did it, and it worked. So this is the object that we pushed into DynamoDB, and now if we go into this table, items, scan, we have one new item. Looks good. There is the timestamp in the Unix timestamp format and the ISO format. Looks good. So what happens if I call it again? There will be a new record, I guess, a couple of times. 2 new records, 3 new records, great. Also, CloudWatch events every minute will call it, right? You didn't forget it. So if I now remove all of these, you know, a new log, a new record should appear every minute because of our CloudWatch event schedule trigger configuration, which you can disable at any time, but you will just keep seeing records coming every minute here. We'll be back to this later. Very simple example, very simple table, but you can design any kind of cron job with the very same mechanism. And they will keep coming. So a very, very last example, I want to show you how to actually use DynamoDB as a source, not only as a data store for your Lambda functions. So we want to execute a Lambda function every time a DynamoDB record is inserted or updated. This gives you some real cool powers because you can design any complex system. You can, I like to say, augment your DynamoDB table with, for example, custom fields or aggregated values or external data integration with just a very simple Lambda function. So let's see how you would do this with Lambda. So we go back. We can use the very same table we just created. Let's make it smarter. Let's make every record more rich, for example. So we create a new Lambda function. Again, we could start from a DynamoDB blueprint. Yeah, DynamoDB in Python. We want to use the log time DynamoDB table. Let's say only one item at a time, because actually the events will come in a batch format. So you will be processing, I don't know, 100 or 50 records at a time because you have a very high throughput. In this case, we want to process each single record at a time just to not have any delays. Right? So the logic will be very similar to what we just did. The only difference is that we will need to check that the event is an insertion. It's an insert event, not an update. I will tell you what's the point here. So the event that DynamoDB will give us will contain many records. So first of all, we retrieve the records, we iterate over them. I like to log everything, so please use logging into your Lambda functions. And here we retrieve for this record the event name. It could be insert, it could be modify, it could be any other event. In our case here, just to keep it simple, we want to to do something only whenever a new record is inserted into the table. Okay, so what we're going to do, we're going to add a new field to our record. We will call it new field, and we will give it a value, which is in this case static. We will call it hello. Very, very simple. So DynamoDB is a schemaless, meaning that you can add any field you want, anytime you want. You will not break anything. So how do we do it? First of all, we retrieve the timestamp, the primary key, because we will need to update the same item that was already written. And then we call the update item operation using the same primary key, right, the timestamp, and we set a new field with a hello value. This is a very stupid, simple use case. We just want to add a new field every time an object is created on DynamoDB. And then we simply print how many records we just processed. Guess what? We can reuse the same IAM role. So the DynamoDB time role. So we have the full access to our table. We just need to put a new item. Next. Oh, we didn't give it a name, so let's say augmented DynamoDB. Next. The integration looks good. Only one file, only one record. That's the right table. Let's create it. It's taking some time. Okay, it worked. So what is going to happen here? Every time a DynamoDB record is created, we will add a new field. Is it real? So every minute a record was created, as you can see here. So 5-6 minutes passed, and they do not have any additional record. They have only a timestamp and the date time that we already configured. But our previous Lambda function will keep being executed every minute. And well, we can actually just call it manually. We can call it manually. So we just created a new DynamoDB record. And if everything worked correctly, I would expect it to have this new field. Does it? It doesn't. Something went wrong. Another great example. Let's debug it. Augmented DynamoDB. You go to monitoring. You want to see what happened into the CloudWatch logs. Here. Well, nothing happened. Let's go back to our code and see what happened. So this is the right table. We have taken the records. Updating the item. It looks good to me. Maybe we can try to test it, right? So configure a test event. It's always a good practice, right? You should test your your function before trying to feel lucky. So this is the event. I think we would need a different schema. So we will need a timestamp and a number. Oh, now it's working. So this is interesting. I think it was an ordering problem. So maybe we can sort by timestamp. Not really. Well, anyway, the function is working. That's why there was no error log. But DynamoDB was not showing the new record yet. So every time we create a new record into this table, let's do it again. Every time I call test, a new record will be created. And as you see, right, this just happened. A new field called new field will be added to the record, and the hello value. In this case, it's static, but you could add any kind of custom logic. So if you want to call a third-party service, fetch some data, add it to this record, for example, for data integration, or for, I don't know, you want to localize the IP, or you want to do any kind of integration with your records, you can augment your DynamoDB table with Lambda. Any logic you want to implement. Okay, we did it. Okay, so we are a little bit out of time, but we could go for some questions and answers. So a lot of you have been asking questions during the last hour, and I will try to answer to some of those. Great. So the first question was, does AWS Lambda support only Python? No, actually Python was one of the latest languages supported. JavaScript was the first one, and then Java, everything running on the JVM was supported. You can run Ruby. Any executable binary can be run into Lambda, so you can execute Go code or any other. I'm using Python because I think it's simpler to understand, even if you don't, even if you're not a Python coder. So some other questions. What if I want to import an external module in my Lambda function? These are great questions. I didn't want to cover this because we talked about it during the last webinar. This is a very tricky point because you cannot just edit your code inline in the browser, but you will need to upload your deployment package containing both your code, your function, and all your dependencies. So let's say you're in Python and you have a dependency on the requests module. Well, you will need to install it locally, compile it if needed, and upload a zip file containing both the request folder and your Lambda function. This is how you do it right now. There are a few frameworks that simplify your work, but the same happens with Node or with Java. You have to build your deployment package. Of course, you can automate the process because you, for example, if you're using a Mac or Windows, you can't compile this code into your machine. You have to compile it into a Lambda compatible operating system, which is CentOS. So this can get really tricky if you have a very long compiling time. Another question, do you have script options to change the stage name to production from dev? This is referred to the API Gateway configuration. Of course, if you have a lot of stages, you want to automate this. Today, I wanted to show you how to do it in the console, also because a lot of operations are already performed by the console. For example, how you give the right permissions to API Gateway to invoke the correct version or alias of the Lambda function. You remember all those little confirmation messages? They were just asking me, do you want me to add the right role, the right permission? Yes, okay. Otherwise, if you use the AWS API, the CLI, or whatever you prefer, you will need to do all those operations yourself, or just use a framework that automates all these best practices for you. Another question. We have many questions. Sorry, I'm just trying to find the best ones, guys. So how do we do the mapping for URL parameters? Okay, so this is how do you design your routing, basically. So you will need to play a little bit more with API Gateway if you want to add dynamic routes with parameters, or you can accept URL parameters. You can add a variable to your endpoint configuration, and also, yeah, an API Gateway will give it directly to Lambda if you use the same mapping template that I used. I was using input. You can use path in order to take all the path arguments, all the path parameters, and you can use the same velocity template to configure your dynamic parameters. Let's see, another question. So about the S3 compression example, will it go in a recursive mode if we try to put a compressed file? Well, yes, if you remember, I was limiting the compression Lambda execution to a prefix and a suffix. So only the images folder and the PNG format were allowed. So with that, I kind of constrained my focus. Of course, if I don't do that, every write to every put to your bucket will execute the Lambda function. Could go in a recursive way. In my case, I managed to avoid it both with the prefix and the suffix. So even if I upload a JPEG or a zip or I don't know, a doc file into the same subfolder, it will not match the PNG suffix. So I was pretty safe, no recursion there. Wait a minute. So another interesting question, do we have to define the memory required for the execution of our code, or Lambda computes it on its own? Well, yes, you have to define it yourself. So if your code needs a lot of RAM, a lot of memory, you have to tell Lambda, I didn't show you, I always use the default value, but you can choose, you have like this handle that will increase both the power and the memory and the networking quality of your Lambda function. So if you give it, I don't know, a gigabyte of RAM, it will also run faster. Of course, it will be more expensive, but let's say that the ratio between the memory you give it and the execution time is constant. So if you give it double memory and it will execute in half of the time, it will pay the same. So I think it's a good deal. You need to find the best trade-off for your specific use case. Can Lambda be used to start EC2 instances? Yes, you can use any AWS API inside Lambda as long as you provide the right IAM roles. So if you have the permission to do something, you can do it in Lambda. If you want to do something inside your VPC, for example, access some resource, some, I don't know, some Redis instance or some EC2 instance, and you need to call it, you will need to add also the VPC security group rules in order to do it. But you can do it. You have to tell AWS Lambda which VPC you want to use, and you will be good to go. We are thinking of using Lambda for batch jobs, but our batch exceeds the 5 minutes. So how do you do it? This is another good question. I think if you need more than 5 minutes, right now it's the maximum execution time of Lambda. So this is what some users are doing. You can execute for 4 minutes and 50 seconds. You know, you can run your worker for as long as it can, and then you can just trigger the same Lambda function at the end of the Lambda function. So you could go in a recursive way. If you keep track of the status of your computation, of your batch computation, you can trigger the same Lambda function at the end. This is possible because you have two variables, the event and the context. And in the context, you can ask it, how much time do I have left for this very execution? So if you know that you don't have enough time to execute the next item in your batch, well, you can just stop executing and code yourself and be recursive. This is not ideal. I think Lambda, it's not a perfect use case for this, but if you really like Lambda and you want to go for it, I think this is the only workaround at the moment. Another question. So is using the AWS console encouraged or suggested to configure all these operations? Well, of course you can use the CLI, the console, I mean the terminal, the APIs. And for most of the operations that I've shown you today, I would actually recommend to automate the process because it takes some time, some practice. Using an API will require a deeper knowledge of what you're doing because you can't just click here and there. So you will need to know a lot of lower level details that the browser console will solve for you automatically. But yeah, I think it's much more recommended to use some kind of automation tool or your own scripts to automate these tasks. Another question. I'm not sure if we have more questions. So would it be possible to use a Docker image with all the libraries and stuff you need? So why do you want to use, so you would like to use Docker as a deployment method. I think this is not currently supported. I know that there are other serverless platforms that allow you to use Docker, but I think if you use Docker, there are better solutions to deploy your code and your applications. I think in Docker you can run anything, and if you just need a function in Python or JavaScript, Docker is like an overkill. So this is why Lambda is simplifying the software engineer and the developer workflow, because I don't even need to I don't want to configure Docker or the whole infrastructure operating system layer just to run a function in the cloud. So it's not possible, and I actually wouldn't do it, honestly. Okay, thank you very much for attending. We are already out of time. And so we will have 3 more webinars this month, and I recommend you to register for them, and also to visit cloudacademy.com/webinars and have a look at the previous ones. I found the last webinar about serverless computing and the serverless framework really interesting. You want to give it a try if you didn't attend. And I'm looking forward to the next one. Thank you very much. I hope you learned something useful today.